In the last video clip, we arrived at how to choose our base and then the corresponding height of a triangle in order to obtain the area of the triangle. Here we have three examples. We are asked to find the area of each of the following triangles. In two of them, the height is provided, and in one, the height is not provided. Let's start with the first one. Hold on, please. In this triangle, we are given two sides, one 11 centimeter, the other 10 centimeters. And then we are given the height 8 centimeters. Which of the two, 11 and 10, will be the base? Now, from our definition that the height is always drawn from one apex to the base, you will agree with me that in this triangle, that 10 will serve as the base of the triangle. So, let's set out there. Which means that the base of this triangle will be what? The base of this particular triangle is going to be 10. And the corresponding height is what? The corresponding height as given in the diagram there is 8 centimeters. The area, of course, is what? Half base times height. So that will be half times 10 times height, which gives us, as we have here, as you can see on the board, that will give us half times 10, that is 5, 5 times 8, and that will give us 40 centimeters square. That was a very straightforward one there. So you can see that the 11 in this case is redundant. We don't need it because we only have 11 centimeters, but the corresponding height for it was not provided. Let's look at the next question. Now in the next question again, you can see the height provided as 12 centimeters. Of course, as we know that the height will always be drawn from one apex to the base. The base in this case will be 9 plus 5, and that will give us 14. So I'll say my base is what? The base in this case is what? Is 9 plus 5. And the height, you will agree, is what? Is given as 12 centimeters. So our area will therefore be half times what? 9 plus 5, which is our base, plus, that's a plus, 5, then times the height, which is 12. And that gives us half times 14 times 12, which is 7 times 12, which will give us 84 centimeter square. And lastly, we look at the last question here. We have to find the area of this triangle, and we cannot find the base. The base has not been provided. But looking at this triangle, this is an equilateral triangle. All sides are equal, and that makes it a symmetrical triangle. I will just simply do something that's okay. Let me take this as my base. If this is my base, then the height will be this length. I'm sure you will agree with me. There. That's the height. And since this is an equilateral triangle, which is of course symmetrical, drawing this line this way will divide this base here into two parts, 5 centimeters and 5 centimeters. I can therefore employ Pythagoras Theorem to get my h. I can say, okay, looking at this triangle, let me call this A, I call this maybe B, and I call this C. You can see a triangle ABC as a right angle triangle, where we can say that 10 square is equal to h square plus 5 square. That is the hypotenuse square plus h square, equals to h square plus 5 square. And solving for this, let's take a look at the next slide. Solving for that, we have that h is equal to 8.66. Now that we know the height, we can now go ahead to do what? To find the area of the triangle, because the height was not provided, but we have technically been able to obtain the height from the provided information. Remember that we had to employ Pythagoras Theorem at this point there to obtain the height. So next, we can now get what? The area of the triangle. Area of the triangle, of course, is going to be what? Half base times height. That's wonderful. Our base is 10. And of course, our obtained height is 8.66. Of course, 10 times 8.66 will give me 86.6 divided by 2. And that gives us 43.3 centimeter square. So we can see how to obtain the area of a triangle where we know the base and we also can find the height. In our next video clip, we're going to extend what we have studied so far to triangles where the height has not been provided. Rather, one of the angles, say this angle or the other one, or probably this other one is provided. How do we find the area of a triangle where we do not know the height? Rather, in place of the height, we are provided with one of those angles. See you then.